I give you all a quick overview of the whole workshop. Now, this is an illustration on the computation of peak discharges and hydrograph using MSMA. Inside MSMA, they have stated how we should compute our peak discharges. So this illustration summarizes up how to go about the computation of the peak discharges and also the hydrograph with MSMA. So MSMA stated that for area less than 0.8 kilometers square, you can use the rational method. You can use the rational method for area less than 0.8 kilometers square. Using the rational method. This is done in workshop number 1. MSMA also stated very clearly that for area above 0.8 kilometers square, you must not use rational method. You must use a method called the hydrograph method. The hydrograph method. So under hydrograph method, there are two methods. One is the time area method. This is done in workshop number 1 also. Another method is the runoff routing method. Workshop number 2 today. You see? I also mentioned last couple of days during the workshop, I mentioned compared to all these methods, the runoff routing method is much more accurate. Why is it accurate? It is accurate because runoff routing method allows you to calibrate. It allows you to calibrate the model. And because of the calibration, this model tends to be more accurate compared to the time area method and also the rational method. I also mentioned that the time area method and the rational method, the results are a little bit difficult to predict. It can be out if you do not do it properly. Because these two models, there's no calibration. So different people will get different results. So be very careful about this rational and time area method. Whereas the runoff routing method, I tend to have more confidence. Why am I more confident? Because by looking at the calibration, I will be able to tell how good is the model. Because you must do a calibration. A calibration means you must use the model to reproduce a historical event. You must use the model to reproduce a historical event. But in situations where you do not have historical data, can you still use this model? Yes, you still can use this model in situations where there is no historical data. For example, if you're doing a catchment, there's no streamflow data, there's no rainfall data, but you can still use it. What you can do, you can calibrate this against the hydrological procedure. For example, HP11. You can use this model and calibrate against HP11. And by doing the calibration, you can verify the model. You can calibrate and verify using HP11. See? So, there's no problem at all if you do not have streamflow data. You can use the hydrological procedure to calibrate. And generally, the results doing it this way is still very good. This is a summary of the computation of peak discharges according to MSMA. You can't find it in any chapter in MSMA, but if you read the whole document, in many chapters, in many paragraphs, in different paragraphs, in different chapters. And this is what it's trying to say. This illustration show you what are the alternatives to MSMA. What are the alternatives? Besides MSMA, you can also look at flood frequency analysis. Besides MSMA, the method just now. You can also look at doing it using flood frequency analysis. This means that you use the historical stream flow data to analyze for the statistics, to analyze for the distribution of the stream flow. Another method is the empirical hydrological procedure. The procedure I was mentioning just now, HP11, is one of them. One of the methods I mentioned just now is inside here, HP11. Also HP5, HP16, and HP4. These are the hydrological procedure you can use. This is just a schematic showing you the rainfall runoff process inside a catchment. A schematic. So the design storm, you have a design storm falling onto the catchment. It will fall into the catchment and it will slowly flow into the nearest stream. Flow into the nearest stream or drain, and flow inside the drain and slowly exit at the outlet. It will slowly exit at the outlet, and when it reaches the outlet, you will route it through a detention basin and come out from the detention basin. So this design storm is to calculate the design storm, it means you calculate the intensity, duration, frequency data, IDF data, intensity, duration, frequency data, and this is done in workshop number 1. And the hydrograph, once the rainfall reaches the ground, it will translate. It will travel on the ground and reaches the stream and flow into the stream. And this method is called the hydrograph method. You use a method called the hydrograph method to describe this process. The process where the rainfall onto the catchment and flows into a stream and reaches the outlet. We use a model called the hydrograph method. The hydrograph method, there are two. One is the time area method or the runoff routing method. Time area method we did in workshop number 1. Runoff routing method in workshop number 2 today. And when the outflow reaches the outlet, it will be routed through the detention basin and reservoir routing, level pool routing through the detention storage. This part we use a method called level pool routing, and this route the flow through the detention storage. This is also done in workshop number 1. The design is in workshop number 3. The theory is workshop number 1. So when it reaches the outlet, we use a model called headrest. This one tomorrow workshop. So you can see, for today we are doing the runoff routing. Tomorrow we are doing the headrest.